start with 5th lecture of Mat 303. In the previous lecture, we have learned that sin z equal to e raised to iz, e raised to minus iz divided by 2 pi, and cos z is e raised to iz, e raised to minus iz divided by 2. In today's lecture, I start with 62. As per my notes, sin minus z is e raised to I minus z minus I minus z divided by 2i. So this is equal to e raised to minus iz minus e raised to iz divided by 2i. So if we take minus sign in common, it is e raised to iz, e raised to minus iz divided by 2i. So it is minus sin z. So we have sin of minus z is minus sin z. Cos of minus z, e raised to I of minus z plus e raised to minus I of minus z divided by 2 as per definition. This is equal to e raised to minus iz plus e raised to iz divided by 2, and this is cos z itself. So all these things are very easy. Prove that e raised to iz is cos z plus I sin z. So we start with this side. Cos z plus I sin z is equal to e raised to iz, e raised to minus iz divided by 2 plus I e raised to iz minus e raised to iz divided by 2i. Now we may cancel out this I, and adding both these terms as they have the same denominator because I was cancelled. So it is e raised to iz plus e raised to minus iz plus e raised to iz minus e raised to iz, and all these things are divided by 2. So these things are mutually cancelled, and therefore it is 2 times e raised to iz divided by 2, and therefore it is e raised to iz, and this is actually something similar as the Euler formula. Sin z1 plus z2 is sin z1 cos z2 plus cos z1 sin z2. We are going to prove again from the right hand side. Therefore, sin z1 cos z2 plus cos z1 sin z. Sin z1 plus z2 is sin z1 cos z2 plus cos z1 sin z. It's a well-known formula, but for the angles, right now we have z1 and z2 as a complex numbers. So we start with the definition. E raised to iz, as there is 1, so I am writing 1 there, minus e raised to minus iz1 divided by 2i, e raised to iz2 plus e raised to minus iz2 divided by 2, this is definition of cos z2, plus e raised to iz1 plus e raised to minus iz1 divided by 2 e raised to I z1 z2 minus e raised to minus I z2 divided by 2I. All these are definitions of the cos z1, sin z1, cos z2, sin z2. Now we simplify. If we multiply this denominator, 4I is in common. So this is equal to 1 upon 4I. And now we are simply taking open the bracket. Now simply we are going to open the bracket formula, and therefore e raised to I z1 plus z2 plus e raised to I z1 minus z2 minus e raised to minus I z1 minus z2 minus e raised to minus I z1 plus z2. How it is? E raised to I z1 plus z2 e raised to I z1 minus z2 minus e raised to, we are taking minus I in common, z1 minus z2, and lastly minus it is again minus, and therefore e raised to minus I is in common, and therefore it is e raised to z1 plus z2. Now we simplify this bracket, plus e raised to I z1 plus z2 minus e raised to I z1 plus z2 plus e raised to minus I z1 minus z2 minus e raised to minus I z1 plus z2. Again we see this e raised to I z1 plus z2 e raised to I z1 minus z2 e raised to minus I, we are taking minus I in common, z1 minus z2 e raised to minus I is in common, z1 plus z2, and we complete this bracket. Now you can see there both these terms are equal but opposite in direction, opposite in sign. Which other terms are same and opposite in sign? Other two terms are same and opposite in sign, and therefore we may cancel out with the help of this. Now, e raised to I z1 plus z2, e raised to I z1 plus z2, and here both of these terms are with negative sign, minus e raised to minus I z1 plus z2, and though we have so this is equal to 1 upon 4I 2 times e raised to I z1 plus z2 minus 2 e raised to minus I z1 plus z2 e raised to I z1 plus z2 e raised to I z1 plus z2, and therefore it is twice e raised to minus I z1 plus z2 e raised to minus I z1 plus z2, and therefore it is twice, and therefore we write it here twice. Now I am taking 2 is in common, so 2 will be cancelled out, and this is formula for sin z1 plus z2. So it proves by using right hand side to left hand side. The same formula is 65a and 65b. Now I leave something for you. And start with 68, that is hyperbolic functions. So we start with hyperbolic functions. This is also one special branch in mathematics. As we define the trigonometric functions, these are hyperbolic functions. 68. And the symbol is sine hyperbolic y is real number, and x, this is a notation, this is a symbol to represent that now we are writing hyperbolic functions. E raised to y minus e raised to minus y divided by 2, and cos hyperbolic y is e raised to y plus e raised to minus y divided by 2. These are sine and cos hyperbolic functions. You should keep in mind. Sin iy e raised to iiy minus iiy 2i. Now this is a simple formula for sine function, means e raised to iz minus e raised to minus iz divided by 2i, and here we applied for I bar. So as per my note, this is 69. We are just going to prove it. So this is equal to e raised to minus y e raised to y divided by 2i. Now what we will do? As I said earlier, if you multiply this by 1, means it is by minus I square. So 1i will be cancelled here, and by using the sign of this negative, we can change the order of e raised to y, e raised to minus y divided by 2, and therefore this is sine hyperbolic y. Now likewise, if we apply the same for cos iy, this is 70 as per my note. So what is sine cos iy? This is equal to e raised to iiy plus e raised to minus iiy divided by 2. Now this is equal to I square is there, I square is minus 1, so e raised to minus y plus e raised to y minus I square will be 1, and therefore this is cos hyperbolic y. So keep all these things in mind, we will use these after some time. 71. Sin z equal to, what is sin z equal to? Sin x plus iy. Before I go further, I would like to do one thing more at that, and that is definition of sine hyperbolic and cos hyperbolic. You will find something. Will you find something? Okay, I am taking up onwards. Just see. This is equal to sin x plus iy, sin x cos iy plus sin iy cos x. We are applying the sine formula as we proved as per my notes in 64, because 64 64 is cos Iy? This is this is cos hyperbolic y. Cos Iy is cos hyperbolic y. Cos Iy, cos hyperbolic y. What is sin Iy? That is sin hyperbolic y. With I. And therefore, this formula is sin x cos hyperbolic y plus I sin hyperbolic y cos x. Now you should keep one thing in mind. What is this? Whenever you write, see here, whenever you write, say z equal to 2 plus 3i. So, actually it is 2, 3, coordinate 2, 3, as we learned in the previous lectures. But what is mod of that? That is square root of 4 plus 9, because 2 square, 3 square. Likewise, we can find the same value. What is sin z square? Means mod of this, what will be with us? And at that time it is sin square x cos hyperbolic square y sin hyperbolic square y and cos x. Where is that? I think you understand. This is 2, this is 3, as I am giving example at that. Cos hyperbolic square y minus sin hyperbolic square y, what it will be? E raised to y, e raised to minus y divided by 2 square plus e raised to y minus e raised to minus y divided by 2 square. Just I am writing the values. Sorry, minus is there. So this is e raised to 2y minus 2 e raised to y minus y, so it is not there, e raised to minus 2 minus e raised to 2y minus 2 plus e raised to minus 2y, and all of they have the same denominator, it is 4. The value of this is, both these are cancelled, minus 2. So it is plus 2 there, because addition is there. Here it is minus becomes plus, and therefore it is 4 upon 4, and though it is 1. Means cos hyperbolic minus sin hyperbolic will give you 1. And as per my note, this is 72. 72th is this one. But I required here, and though I prove it. So sin square x cos hyperbolic square y is 1 plus sin hyperbolic square y, as per that, plus sin hyperbolic square y and cos square is 1 minus sin square x. Now simplify this, what we will have? This is equal to sin square x plus sin square x sin hyperbolic square y plus sine hyperbolic square y minus sine square x sine hyperbolic square y. Sine square x sine hyperbolic square y sine hyperbolic square y and minus sine square x sine hyperbolic square y, and you can find that both these terms are equal and opposite in sign, so we may cancel out. So this is equal to sine square x plus sine hyperbolic square y. So likewise we can prove this. The another formula is of the cos, and we can prove this by the same way. Similarly, we can prove the arguments and the answers for the cos function, means cos hyperbolic function. Okay, with this we stop here.